Right, here we go. So your group numbers are this, and your group, when it's called, you're going to discuss the answers that I choose to do. I am going to mark a couple things on the sheet, though, and kind of treat this as notes slash homework. So you can see the glorious title I put at the top of this page. The thingamajig, just to get back from break, just a little algebra kind of working some stuff out here. But get ready. The group numbers, you're number one over in this corner, you're two. You're three, I go across this way. Front row, you're four. Just because we skip, we're going to go five, six, seven. Seven in the back, hiding in the shades here. All right, so who's going to be first? Hey, nice, seven, hiding in the shades in the back. Sweet. So get yourself warmed up here as I get ready for what we're going to be doing here today. But up at the top, I like the worksheets that I found for this from 2 books ago. Prentice Hall, no one cares, but I like this one of the worksheets that has all the drawings up at the top. Just maybe some added things if you wanted to remind yourself. I'm going to do this real quick, and you want to pay attention. I still see some groups working away. Oh, very shaky, Mr. S there as we get back. But if you draw those diagonals, remember in a regular, I can't say the word regular because that means something different, but in a parallelogram, these bisect each other. So we could probably show that. 2, 2, 3, 3. And then I guess we can assume the opposite. I don't know why I didn't do 1 and 2. But mark those as equal. The diagonals are not equal to each other, but what they do is bisect each other. One added thing that a rhombus has, what's the angle measure of all 4 of these angles at these intersections here? What are all 4 of these angles? 3, 2, 1, go. 90. So you got to remember that, hopefully, that for a rhombus, not only are they equal, they make a right angle in there. They're perpendicular bisectors of each other. So if you wanted to mark those as equal as well, go ahead. It gets a little tougher, though. If you can kind of remember that a rhombus is a parallelogram, so it shares the parallelogram properties. That's a good thing to do. For this one, these are equal to each other. The diagonals are equal to each other in a rectangle. It's a little bit added to what happens with a rhombus. They're not perpendicular bisectors, but what this is all 4 of these are equal to each other. So we can mark that and just really treat those as the diagonals are equal, and they also bisect each other. So all 4 of those little segments are equal to each other. That's different than a rhombus. A rhombus has what the parallelogram has. They bisect each other, but they're not equal. And I think that's easy to figure out because it looks like this one's longer than that one. And I told you in before break, in the 2 days, you can kind of cheat to kind of have that stuff happen. For a square, it has all of those previous properties. They're definitely equal to each other, and they're definitely perpendicular to each other. So really what you have now is 4 45, 45, 90s. And I could mark that as 2 and that as 2, and then you could go all the way around. So diagonals are equal, and they're perpendicular bisectors of each other, so therefore all of that is true. You can mark it any way as you like. Just it holds all the properties of all those previous things. One thing you should definitely be looking at is this, if you remember at the end, who is what, and that's really how the worksheet starts. And the first people I have are going to get a particular number there, and we're going to look at that. Kite, a little bit different. You can cheat on this, though. Obviously, these diagonals are not equal. Boy, am I out of practice. But hopefully you can surmise that the first one that I drew left to right, this is way bigger over here than this part. So this is certainly not bisected. But you know how a kite works if you ever built one together? I think you can assume and know that these are right. And it certainly does look like that this is bisected here. So I got to get 3 marks in there because of the 1 and the 2 marks marking that as a kite as it is. So again, kind of like forcing in the diagonals within this drawing, kind of helpful. Trapezoid and isosceles trapezoid. One thing about this, boy, really out of practice with writing. Doesn't look like it because of my awful drawing. The diagonals are equal. they don't bisect each other, but they do cut them into equal proportions, I guess is the best way you could say that. That's the best way I could show that the diagonals are equal. Therefore, those little parts of each diagonal are equal. The top part is equal to that top part. The bottom is equal to the bottom. So that's one way we can mark the diagonals being equal, and so on and so forth. Okay, I'm going to get all three of you here. So I'm starting with 6. Now, anything I don't do today, it's homework, and basically, everything should be done as you walk in tomorrow. We start slow, and I like 6. So let's start with Ella. What? Number 6. What did you guys start? Is it a parallelogram? Yes or no? Okay, is it a rectangle? Yes or no? We said yes. Is it a rhombus? Let's move to Nicole. Yes or no? Oh, okay. So did you say it was a square? Yeah, and you and this is why I picked 6 on purpose. If you got a ruler, this literally may be off by like zero point 0.1 millimeters compared to this side right here. The point why I picked this one is you cannot assume a drawing without it being marked properly. So are these sides marked as equal, this one and this one? Yes or no? No, so you can't assume it. So let me ask you one more time, is it a rhombus? You don't know it is. Is it a square? No. And is it any of the rest of them? No. So actually, that's why I picked that one. You cannot assume a drawing. It must be marked. All right? All right. Then Jacqueline, I don't know. Let's go to 8. Let's just pick 8. Parallelogram, yes or no, Jacqueline? Ooh. Okay, so what does this symbol mean to this one comparatively? What does that mean those two sides are? Parallel. And what does it mean about these two sides? Definitely parallel. So is it a parallelogram? That is the definition of a parallelogram. All right. The sides opposite of each other are parallel. And then there's some more features, but we got other markings that we can continue. Is it a rectangle? No. Is it a rhombus? Ooh, so here's the thing. If this is equal, there's something I'm kind of like short on this, but we're gonna make assumptions here. These two sides are equal, and then we have this parallel thing going on here. Then it's nearly impossible that these. I mean, it's already a parallelogram, so we know opposite sides are equal as well. So we can guess that this side is equal to this one, and I got to get rid of some of my markings. And then we can, since we know it's a parallelogram, these opposite sides must be equal. And all of a sudden, all 4 of them have 1 mark. So I'll ask you again, is it a rhombus? Yes or no? Yeah, now it is, because we have all 4 sides are equal, and that's what makes a rhombus. Is it a square? No, there's no right angles. It's not a rectangle. Couldn't be a square. And then I'm not even asking about trapezoid, isosceles, or kite, because those are a different offshoot. Like I said, you want to be looking at this and remembering, parallelograms, rectangles, rhombus, and square, they're all in that same family. These other ones have way different properties. So therefore, they're in a way different family or offshoot there. So I picked a couple tricky ones. I think 7 is pretty simple. So it was probably 10, 11, 12 for sure. And 9, can't assume if it's not marked. So I'm just telling you it's not isosceles because it's not marked as such. All right, I'm going to go back and forth. I'm going to go through page 1 and then do a pause. Hopefully I can pause the video. I think someone showed me how to do that. I forgot where it was at. Someone showed me. I'll work on that when I leave you alone here. But next one. So find the value of x in each parallelogram. Again, this was kind of a simplistic worksheet. I just wanted to get the thoughts flowing. So I'll finish this first page. I'll leave you alone. Nice. Students number 2 over here. You ready? Ready? Who we got? Good. We'll start with Cameron. I get it. My fat face is in the way here. I got to move that. All right. Boom. Okay. So what's true about parallelograms and their diagonals? So simple. They're equal. So tell me the equation I would set up. Mickey Mouse. This is so simple. Again, just kind of, dealing with our simplistic ideas of what these are. And then what's x equal? X equals 8. You subtract 3x, you do get x, and then you add 10, you get x equals 8. And it really does just say find the value for x. So that's really what's going on with that. Simple. We'll make this more challenging as we move. I'm going to make you go to the next page. I'm going to pause, have you discuss, and then pick groups on this one. And I think I like them both. So I will do 16. We're still on this. So Rihanna. All right. I don't care where you're at here. We are going to go in order, though. Sorry, I kind of gave that away. What's angle one's measure? 113. So again, this is just dealing with the idea that opposite angles in a parallelogram are congruent. Then I'm going to ask you, what do you think angle 2 is? Go ahead and tell me that. Okay, so angle 2 equals 45. If this was like my daughter has to do, the reason you would say those are equal is because those are alternate interior angles with these two sides being parallel. Now, they're not marked, but it does say in the question this is a parallelogram, so we can assume those are parallel. And I'm just going to mark that one for the purpose of why angle 2 is 45. All right, and then Allison, what's angle 3 then? Allison, what's angle 3? The same reasoning. We should be able to kind of come across, and get what angle 3 would equal. So angle 2 is 45 because these are alternate interior. So what's angle 3 got to be? 22. Okay, so we got to get that pretty quick there. I don't want to remark that because it's hard to mark those as alternate interior angles and go from there. So this happens for a parallelogram. Same for a rectangle, a square, and a rhombus because all three of those are parallelograms. All right, go to the second page now, and I'll do a little pause and you guys discuss these questions. And I'm going to grab a few here and there, okay? All right, I'm going to see if I can pause the video, though. I don't know if I can. Someone showed me how to do this, and I don't know where it's at. Here we go. Samuel's fumble. I hear people laughing over there. All right. Okay, help. I definitely need help.
Oh, you're using the extension?
Yeah.
I think if you click on the extension in the top right corner.
So if I do that again, if I hit, where'd it go? Now it's gone. Where is it? Oh, so it's saying I'm recording. I got it. I think we're going again. We'll see how this tapes and is good. Okay, so now Evan, when you look at questions, it's amazing to me that people mess this up all the time. So before we continue, 7, 8, 9, 7. What are the variables on? Are they on sides or are they on angles? Sides. Number 8, what are they on? Sides or angles? Sides. Number 9, what are they on? Sides or angles? Angles. Okay, so some people screw that up. It actually blows my mind that they find X and then they put degrees on the answer or something like that. There really should be like feet, inches, miles, like some labeling on 7 and 8. But usually they just expect you to put like units if they expect you to find the sides. So that's all that's happening there. And then find the values of x and y forwards. The figure must be a parallelogram. I think we know what to do on 7 and 8. We know the properties I just stated here. Let's go to 9, and hopefully you're fine on 7 and 8. So, Evan, what's true? What are some equations that are true here?
12y plus 8 plus 5y plus 2 is equal to 180.
All right, and I think that's the one we're going to stick with. There's a whole bunch of things that are true, but this one, when I set this up, you have one variable. What'd you say it equals? Sorry? 180. All right, so property of parallelograms is consecutive angles are supplementary. It's because they're same side interior angles. Same side interior angles are supplementary when the sides that the transversal cuts are parallel. I said that very bad, but anyway, Vicky, and then what's next? Tell me what you'd have as you solve this. Just go ahead and solve an equation there. Mm-hmm. And what do you end up with?
17y plus 10
Equals?
180.
And then it's a very simple solve. What does 17y equal?
170.
And then what's y equal? Okay, now another thing that's true, this happens on the previous two questions, is opposite angles are equal. But when you set 2x equal to 12y plus 18, you now have two variables. This wasn't something you needed to set up a system. You could set that equal and then solve for one of the variables. And then these are supplementary, but you're making this too difficult. Just solve for y, plug it back in. 10 times 12 is 120, so this is 128 degrees. Now back to Evan, how do you find x if I'm still making you find variables? Okay, divide it by 2, because what's true then is 2x degrees must equal 128. So this is not, and nor are the previous two, is it necessary to solve a system, so to speak. I don't know, I can't think. 64, is that right? 64? All right, so x equals 64. There's the solving of the two variables. Not really a system. I gave you true systems of equations before break on those. All right, these three, really care to just do one of the three? I really should make it like random. Nice, team one, sweet. All right, we'll start with the jack attack here. Oh, I don't know. I think I did angles before. That one's kind of stupid. 10's easy. So let's like tackle 12. I think that one's got the most going on there. Tell me a true equation, Jack. What's going on? Shh. Group number 4, you're messing up with Jack. He can't even concentrate.
50 equals 2x.
50 equals 2x. Very simple. All right, so alternate interior angles are equal. Not even going to insult your intelligence on solving for x there. All right, but then, I don't know, since that was too easy, what do we have there, Brody? What is this angle measure then? Very simple. What do we got to do? Okay, so that angle measure is 4 times 25 minus 10, and that ends up equaling what, Brody, just to say a number today? 90. So that angle measures 90 degrees. That's weird. Doesn't even look close to 90 degrees, but you never trust the looks. And then who do we got over there? That's Jackson. What's this other angle measure here? What's that measure? Very simple. 40. It doesn't look 40. Maybe it looks a little bit like it's 40 degrees. So just the ability to plug in. So very simple. Move on to the third. Wait, we have one more on the bottom, don't we? Is this one more on the bottom? Okay. Yeah, we're going to hit one of these here. All right, I'll get a different group here. So real simplistic for those guys. Number 7, nice. How lucky you are, Ella. All right. Okay, so I'm going to go to 6. Boom shakalaka. Okay, so what do you find in here? Sides or angle measures, Ella? 3, 2, 1, go. Angle measures. So they're kind of not really showing arrows. You know, you got to really work on what are they trying to find here. Maybe I would say probably you don't really go in order here. Let's start with angle 3. Let's see if you can visualize what angle 3 would have to be and why I'd find that first. What's angle 3? 68. This is an alternate interior angle situation. So when I look at angle 1, that's not really the first one I think I could find. And then actually the next one I should be able to find is angle 4. What's angle 4's measure? Hold on. Where are we at here? Let's go to Nicole. What's angle 4 measure? 90. Why? What is this a picture of? Ultimate. What's the most specific name for this drawing? Don't just say parallelogram. It's much more than that. A rhombus. So a rhombus, the diagonals are perpendicular bisectors of each other. All right. Well, actually, I think we could kind of do some stuff here. Like, let's see, what do we got here? So we have 90 degrees here. We have 68 here. Ooh, I'm trying to think how we would go over this here. So 68. Man, let's see if Jacqueline, you have a reason for what angle 1 or angle 2 is. How we can actually get this figured out. Do you have anything for that? Yes or no? I'm trying to think how we could bridge off of this here because we can't. So we got this is equal to this. These whole angles are equal. All right. So we do have that problem here. I think I know what we can do. Let's find this angle measure here. This one's not so bad. So I don't know if I could get that actually in there pretty good. This one right here. What's that angle measure, even though they are not telling me to find that one? Okay, where'd you get that from? 42. Oh, you're close. I think I know what you're trying to do. 42 plus 68 that's 110. That's actually too much. So what are three angles in a triangle? Three angles in a triangle. What do they add up to become? 180. Actually, now I know what I screwed up here. So these should add up to 180. So we could do that. So what's left over? If this is 90 and this is 68, what's left over? It's not 42. That's too much. If you made that 42 right there, then that would be 200 degrees. So 22. Okay, so that angle is 22. Now, what does that help you find? What angle on this page is actually also 22 degrees? Angle 1. Okay, and the reason is, and this is what I forgot. Actually, sorry, that's a brain mishap. This is 22 degrees. One thing I forgot is these are bisected and these opposite angles are equal. So I could have done something a little different than that, but I just wanted to hold in the 4 and 3 being found that I was going to do a triangle thing, 180 minus. And now I know that these are equal to each other. All right, so then I should have been able to find angle 2 right away. Jacqueline, you know what angle 2 is? Use the same idea that these opposite angles are congruent to each other and bisected. So what's angle 2's measure? 68. Okay, so that's 68 because it's equal to the 68 over there. So that was the one thing I forgot. We could have got there probably a lot quicker. But that's the idea of these, really practicing and knowing your properties for each of the drawings. Know that number 1 is also a rhombus. Number 4 is also a rhombus. 2 is not, and neither is 5. All right, so careful and tread lightly on that. All right, go to page 3. Take a little break from the movie, and then we'll hit the idea of trapezoids real quick. So just a little practice, that's all. Little thingamajig to get ready for the next part. The last time. Okay, so to end this off, the last page, just a couple easy trapezoids. Not going to insult your intelligence by asking about 1 through 6 here. Basically, we should know with isosceles, trapezoids, which all of these are marked as isosceles, luckily. The lower base angles are equal. And then these, even in a trapezoid that's not isosceles, same side interior angles, these are supplementary. So that's what's going on there. Hopefully you heard that. Because Charlie, I think 7 is pretty simple and straightforward. I wish they would say find all the missing side measures instead of just find the values of x. Obviously, these are marked as equal, so that's a very simple, basic progression here. But I'm going to look at 8. Charlie, what is a true equation I can set up for number 8 here?
I have 180 minus 4x equals 6x.
Okay, that's a strange way of looking at it, but it is true. I'm going to write this in probably a little different way. What you told me by your other equation is that these do add up to 180, so they are supplementary. So again, this is not, don't trick yourself that this is some sort of, I have to find solve a system because there's x's and y's. So, kind of still a basic worksheet. And then, Will, what'd you get for x when you solved on this one? I think I can.
X equals 80 degrees.
Okay, so x equals 8, and then you would plug it in. So 10x plus 20 equals 180. And then 10x equals 160. What does x equal?
I had x equals 80.
So I didn't solve that incorrectly, did I? Right?
I think I.
Yeah, something went wrong. So what's x actually equal?
It equals 60.
Okay, and then back to Charlie. How do I find what the variable y is equal to? First of all, who is y equal to? This angle up here or this angle down here?
6x plus 20.
The 6x plus 20. So what do I have to do with that? And you might have to make an adjustment if you didn't have x equals 16. But what do I have to do to find y?
You fill in x with so it'd be 16 times 6.
Yeah.
20.
And then 6 times 16, I think, is 96. Is that right? 106, 116 then?
Yeah.
Okay, so y is 116, which does give me what that both the upper base angles are actually equal to. Then we could find, obviously you can plug in 16 times 4 to find that one. Interesting. Number 9 is weird. Look at number 9 real quick. There's that group 4 again. All right. I had our own little page over there. Okay. There's only one equation that I could set up here. I was looking at it this way. There's something wrong. Because I can only obviously set 7x equal to 2y plus 5. And then we got to remember something with solving systems. I need 2 equations with 2 variables in order to solve. I don't have any other relationship I could figure out. But does anyone know what both x and y would have to equal at least one answer that would make these two sides equal? What would x has? Raise your hand if you know. This is not a group thing. You got your hand up? Yeah. 1. Okay, because if I plug in 1 for x, I get 7 times 1, which is 7. You never should do this, by the way. And then y, if that equaled 1, 2 times 1 plus 5 would equal 7 as well. So very strange question. I think this is kind of one of those mistake questions. Which one? I forgot. Which one did you guys say that didn't work out? Was that on the previous page?
Yeah, it's
What number was it?
11.
I said I was going to do it and then I forgot. And don't worry about the numbering. I keep the numbers from a worksheet that I grabbed so I can look at the key to the answer. So I keep those numbers all the same. But look at what the directions are. And this is something I can add to this. And we'll do one more thing after that. But number 11, what's true or what should be true if this is a parallelogram is a couple things. Probably what you would have done is set these two equal to each other. So 2x equals x plus 30. Group 4, you might want to watch this. They're just like a runaway train over there. And then x equals 30. They're still not. They don't care. They couldn't care less. All right. And by the way, that's what it is. You say you couldn't care less. Did I go through this before with you guys? I hate when people say could care less because you know what that means? That means here's the caring curve, the x and y axis. And if you could care less, here's a 100% level of caring. And if you could care less, that means your caring could be way up there because you could care less. When I say I couldn't care less, I'm at 0 for caring. You got it? Yeah. So correct somebody from now on. Remember, I teach you English in this class, not just math. Anyway, that just drives me out. It gets my blood boiling. All right, so 3x minus 15. So there's another little added thing learned from Mr. Samuels. Hold on. I subtract 2x. I add 15. What's going on here? X equals 30, and now x equals 40 in the same question. What does that mean about these opposite angles? Could each set of opposite angles actually be equal to each other? No. So what this means is this is not a parallelogram. And that's what it means. Then tell it whether the figure must be a parallelogram or not. Once we get this inconsistency within one question, then that means the variables given, it's impossible for it to be a parallelogram because we don't have those attributes. Okay, I had some interesting thoughts on this one here, but we'll go ahead and look at maybe one of these. Right, and we're going to run out of time. Probably not. 4, nice. Yeah, good. That group that I've been yelling at on our own little page over here. All right, so who do we got? We got Evan over there, right? Okay, so I'll pick one maybe a little bit more challenging. First of all, probably not so challenging. What's angle 1 in number 11? 90. So that's just practicing the idea that they are perpendicular to each other. And then what's angle 2 and y? Why? Yeah, you got a triangle here. I thought a more interesting question is, would there be an ability to find these angles? Well, first of all, that angle is equal to that angle. And this angle, because a bisection, is equal to that angle. I think there is a way that we could kind of bridge and find those other ones if they put some missing stuff in there. By the way, in a quadrilateral, what do all the angles add up to be in the inside of a quadrilateral? 360. So there'd be some sort of idea with that. This is 25, so this is 25 because that is bisected, and then this would be 65 here. And I'm sure there's something you could do to get those other ones. It's a more interesting question. I don't think we have. Whoa! I just jumped all the way to page 1. Thanks, computer. I don't think anything else is really too big of a deal on that. I think we got something similar with 15 per se. Yeah, I think yeah, I definitely like number 13. That's a real good one. But not too bad. Same idea. It's pretty simple. So, okay, so last one. We'll end with Vicky. Oh, I don't know. Let's look at 17. What would be true about these variables here? Tough one, huh? Want some help? I'll help you out. You want some help?
Yeah.
Okay, so remember that this diagonal is the one that bisects. Okay, so that's the bisector of the opposite angles, and you can kind of see that in the drawing. How many people have flown a kite before? Actually, the old school put the wood together and no? You kids don't do anything anymore. It's all just video games at home. Anyone ever do a video game of flying a kite virtually? Okay, that's great. Perfect. All right, that's exactly what we're looking for. Okay, and then what are these angles? All 4 of these in the middle. Okay, so now what's true? You got it? Okay, so he helped you. So tell me the equation I would write.
5x minus 1
5x minus 1
plus 8x
plus 8x.
plus 90.
There you go. So it's the idea that these are little triangles all the way around, and then knowing our properties there. Okay, I think we're good. I'm not going to solve that. One little thing, I do have to get my calendar going here. So I was a bum over break. I did no math. I actually did a little bit last night to put these notes together. But I did want to reference this too. One little thing before we go. My little Carl Sagan day on Friday. Hope you kind of enjoyed it. I left this document up, and actually, when I do the new calendar, that week is going to be on there. I put some things on here, like when I showed you the first episode, the beginning of Carl Sagan and Evangelist, that song, that haunting music. I put a little clip of Blade Runner here. Anyone ever see Blade Runner? Probably not. Have you? All right, so then I just on Netflix. On Netflix, you know what the #1 streaming movie on Netflix is? Blade Runner 2049, the sequel. It blew my mind after mentioning this in some of my other classes that this is the #1 streaming